So, we're going to talk about primes again. We know we love primes, and there's all different types of primes. We know there's infinitely many primes, but there's all little different categories of primes. So I'm going to show you another one. It's called Wilson primes. There's only 3 Wilson primes that we know of. So let's just write out the 3 Wilson primes. I'll show you why these are special types of primes. 5, 13, and 563. Now, actually, they think there's infinitely many Wilson primes, but we've only found 3 of them. So what's this special thing that they do that other primes don't? Well, one thing that all primes do, I'll show you this. This is what all primes can do. You have a prime, p, minus 1. We're going to do a factorial on it. Do you remember factorial? So you're multiplying all the numbers up to and including p minus 1. So it'd be 1 times 2 times 3 times 4. So if my prime is 5, it'd be 1 times 2 times 3 times 4. Okay, I'm now going to add 1, and that is divisible by the original prime, p. And all primes do that. So in the case of 5, you would have 5 minus 1 factorial plus 1. So what's that? We're talking 4 factorial plus 1. What is 4 factorial? It's 1 times 2 times 3 times 4. And then we add the 1 on. That's 24. So it's 24 plus 1 is 25. And you can divide by 5. In fact, you can do that for any prime. That will work for any prime. And it only works for primes. It doesn't work for composite numbers. We've talked about tests for primes before. We talked about Fermat primes. And sometimes there were liars, weren't there? There were some numbers that weren't prime that passed the test. They were lying to us. This is a 100% test for primes. Only primes pass it, composites fail. Let's do a composite.
Can I choose one?
Oh, you're going to pick a big one. We have to do a factorial, remember, this is the problem.
Let's do 8.
Right, so 8 minus 1 factorial, then we add 1. Right. So 7 factorial plus 1. Okay, so we're going to do 7 factorial. So that is, I wonder what that is, 5,040. I don't show them that. So 5,040 plus 1. So 5,041, but I'm saying that's never going to be divisible by 8, and I don't think it's going to be, is it? So we're going to divide that by 8, and it's not. You don't get a full number, a whole number for that. So, but that's guaranteed. Primes will give you a whole number, and composites would never give you a whole number for that. Yeah, that's called Wilson's theorem, and it is a test for primes. It's not a great test for primes because you have to do a factorial, and they get massive. So you'd have to work out a massive factorial. If it passes, though, it is a prime. So all primes pass that test. The Wilson primes are special because they pass the test twice over. You can actually do it twice over. So you can divide by the prime and then divide by the prime again, and you get a whole number. So all primes pass the test once, but only these 3 that we found managed to do that twice over. I'll show you what I mean. Let's do the 5. Well, we did the 5 already, didn't we? So we got 25, 5 minus 1 factorial plus 1. So we ended up with 25. So we know you can divide by 5. So, 25 divided by 5 is equal to 5. And all I'm saying is you can divide by the prime again. So obviously 5 divided by 5 is 1. So that would work. Other primes wouldn't do that. So we see a prime passing it once and then failing the second time.
I want to see 13.
Do you want to do 13 first?
Yeah.
Let's do it with 13. Let's see what we get. So we're looking at 12 factorial plus 1. Let's see what you've got. 12 factorial. Brilliant. Big number. 479,001,600.
Plus 1.
Plus 1. Plus 1. All right. Let's see if the prime divides it. Do you think it's likely?
Divide it by 13.
Yep, it divides perfectly. Wonderful. But all primes do that. Does it do it twice? Yes, it does. It does it twice. So 13 is a Wilson prime, as is the last one I've got here, 563. Do you want to see something fail, just to check?
Yeah.
Pick a prime.
7.
Yes, let's do 7. Let's do 7. Small, isn't it? Right, first I work out how to clear. That's that one. Right, 7. So we need 7 minus 1 factorial, and then we're going to add 1. So we're talking 6 factorial plus 1. Well, I know 6 factorial, it's 720. If I'm feeling confident, I'm going to say that's 721. Let's see if it works. Now, if I divide by 7, which is the prime, works, 103. Can I do it second time? I don't think it's going to happen, though. Divide by 7 again, then. And no, it's not going to work. So there. So that's kind of nice. It's a nice little prime number fact. There's no great use for it, but why do we have to do everything for application? This is just a great little prime number fact. Now that we know what Wilson primes are, let's have a look here of the Wilson lemma. That was just the original result. That was just this one here. So I'm saying that primes can do this at least once. Let's just see if that's true. So we're going to prove that. So we're going to get some more brown paper. No sneaky composite numbers. No counterexample to this. And they've checked large numbers for this.